Hello folks, welcome to this session. Today I'm going to show you how to make queries to an SQL database with Go, and we will see how to set up your dev environment with Docker Compose. So let's get started. So I've created a new project in my IDE, and then I'm going to open the terminal. I go into the directory of that project and I'm going to initialize my Go module. So Go mod init, and then I type the module path. github.com/maximilian_demo-mysql, and then I press enter. You will see that you will have a go.mod file created. So now we are ready to start our project. In order to test locally our development, I'm going to use what is called Docker Compose. What is Docker, you may ask? So if we take a look at the Wikipedia page, you can see that it's a set of platform as a service products that use OS level virtualization to deliver software package called containers. We will not go deep into that, but I just want you to know that Docker will help us in order to create containers, and in those containers we will be able to run our application, and we will be able also to create a database in order to test. It will be on our local machine. It will be a container running on our local machine. And Docker Compose is something that has been added to Docker that makes it very easy to do. So you will first have to install Docker Desktop. So I'm going to give you the link, but you have the instructions here. So you have the installation for Mac. You can download the installer, and you also have the installation instruction on Windows. So in order to run that, you will first need to install Docker. So after you've installed Docker, you come back to your project, and then you're going to create a new file, and you're going to name that file docker-compose.yml. So it's a YAML file. And in this file, we're going to describe what is our test environment. The first thing that we are going to do, we are going to define the version of the Docker Compose specification that we are going to use in that file. So I write version, then colon, and then I open quotes, and I'm going to put 3.3. Then you are going to write services on the next line, and then a colon, and then you press enter. So generally your IDE will help you to write that. And by the way, here you can note that it has automatically added 2 spaces. So that's how YAML files are constructed. You use 2 spaces in order to indent the file. So here I'm going to define services. So then I have 2 spaces, and then I'm going to define all my services. So I will have a database, but I can also have another service which can be named application. Okay, and then for each service, I'm going to describe what is this service. So it's just named database for the moment, but I need to describe what do I put inside that. Just below database, I'm going to start with image. So this is a property, and the value of this property should be the name of an image. So for the moment, let's put x66 here. Then we can also define the container name. And for the container name, I'm going to name that database, for instance. And then I can set up some environment variables that will be set inside my container. So each service in a Docker Compose file will be a container that is built with what we call an image, and we can also set some environment variables. For the moment, we will leave it empty. Now we need to define which image do we want. So in order to find that, you will need to go to a site that is called Docker Hub. Docker Hub is an image library. Then you're going to click here on Explore, and then you can search for the software that you want to use. I'm going to type MySQL to see what's in here. So here you have a list of images available. What I advise you is to filter only for Docker official images. It's more safe. So here you can see we have MySQL, we have mariaDb, we have Percona, phpMyAdmin. So I want to install a MySQL database. So I have the choice between those three. So MySQL, this is the MySQL original relational database management system. And then you have some forks. And we have the mariaDb fork. So it has taken the code from MySQL plus added some code and modified some code. So we say it's a fork. And you also have Percona. So what I use is generally mariaDb. So I'm going to go for mariaDb. And then I need to find the image that I want to use. And each image has what we call an image tag. So you're going to check here what you want. So here you have the tags that are supported. So what I'm going to do is I'm going to select the latest one, which is 10.10. So we need to say in our Docker Compose file that we use mariaDB at the version 10.10. So what I do usually is that I copy that, so that part, mariaDB, and then I go back to my Docker Compose, and then I paste that, and then I have to give a tag. So then I put just 10.10. And you can see that you have, by the way, autocomplete that is provided by the IDE. So we are going to use this image, mariaDB, at the version 10.10. We're going to name the container database, and then we can also provide some environments. Let's take a look at the documentation of the image here. And you can see that you have examples here of environment variable. So we will need to set the mariaDB root password. And I'm going just to copy that and paste it here. So you see we are going to set an environment variable mariaDB root password. So this is the name of the environment variable and the value, example here. I'm going to remove application for the moment. So here it's just for test. So we are going to bootstrap a mariaDB database that will live inside a container, and we're gonna set the root password to example. Then we will need to set up networking in Docker Compose. So as you can see in the documentation, by default Docker Compose will set up a single network for your app. Each container for a service, the database will be a container here, will join the default network. And it will be reachable by other containers, so if you have other containers and other services, and discoverable by them. And here you have an example here. So you can see that you have two services, the service web, and you have those ports for the service web, and the service DB, and you have those ports for the service DB. Let me explain you briefly this concept of ports within Docker Compose. So here it's your machine on blue. And then you have Docker here. Inside Docker, you will have containers. So let's add a container here. It will be the container for web. And then you can have another container. Here, for instance, we have a container for the database. Those two containers can talk to each other. The web can talk to DB, and DB can talk to web. And they're going to do that via a port. So those two containers can talk to each other, but you can also talk to those containers from your machine. You can talk to web, you can talk to DB. And you will talk to them via a specific port. So which port is it? You can see that you have two ports here. A port is a number, an integer number. So here you have 8000 and 8000. Here you have 8001. And here you have 5432. So the first port here is named the host port. What do I have here? So the first one is the host port. And the second one is the container port. Now, let's say that I'm web and I want to contact DB. I'm going to send a request on the network and use the port 5432, the one that is written here, so the container port of the DB. And now, if I'm DB and I want to contact web, I'm going to use the port 80000. That's it. And then if I am on my computer and I want to contact web, I'm going to use which port? 800, so this one. So don't be confused, it's the same here. But if I want to contact the DB, I'm going to use the port 8001. Let's go back to our code. So I should add that ports, and then I should declare the ports that I'm going to use. So ports, then a colon, then enter, and then a dash, and the ports. So let's do that. So it's going to be ports, and then I add a dash, and it's going to be 3006 and 3006. I'm going to use the same port for the sake of simplicity. But remember, this is the host port, and this is the container port. Now it's time for us to run that. So to run that, I open my terminal, and then I type docker-compose, and then up. So I have an error, it says cannot connect to the Docker daemon. So if you have that error, it means that you have to start Docker. So let me start that. You should have this window if you work on macOS. So Docker Desktop will start. Once Docker has started, you can run Docker Compose up in order to start your container. So for the moment, I will have just one container. And you can see that the image is downloading on my computer. And once it's downloaded, it will start this container, and we will have a database. So when you see that, it means that your Docker Compose infrastructure has been created on your local machine. So everything is on your local, on your computer, nothing on the internet for the moment. So if you want to exit that, you can press Ctrl+C, and it's going to stop that. You can use Docker Compose up-d. It's going to detach the process, so you can still use your terminal after that. So that's it. We have installed a database that lives inside a container that we can use in order to test our Go application. So now we can develop the Go application. So what I'm going to do first is I'm going to create a directory internal. Each time I create an application, I'll always create an internal directory. And in that directory, I'm going to create subdirectories, and each subdirectory will be a Go package. The internal directory is a little bit specific. If you put a package inside internal, then you will not be able to have people importing your code in their code base. That's a way to hide your internal details. Nobody will be able to import your code and run it if it lives inside internal. Otherwise, if you put your code on GitHub, anybody can inject that code into their project. So it's a way to protect yourself against usage that you don't want. Inside this internal directory, I'm going to create a new directory that I'm calling storage. And inside that directory, we're going to have the package storage. So I'm going to create a new Go file that I name storage. So here I will create function, methods, types that will be inside the package storage. Then I will create at the root a new Go file that I'm naming main.go. So main.go will be our entry point, and you can see that my IDE has added package main and function main. So this is the entry point of your program. Your program will start here. The first thing that I'm going to do in the package storage is to create a type interface. So we name that interface storage, and we will export it. So it's going to be type storage, and then interface, and then you open and close curly brackets. A type interface is a contract. You are going to define inside a set of methods, and in order to be a storage, you should implement all these methods. So we can have a type MySQL storage, where we will implement all the methods, so it can be a storage. And we can also have another what we call implementation, for instance, MongoDB storage, where we'll have all those methods implemented. So really, the type storage interface will be a contract and we'll define our methods. We will not implement them inside the type interface, but we will just define the name, input, and output. So let's go. What do we want to store? We can store, for instance, books. Let's say that we want to have a software that will be used by a library. So what I'm going to do is I'm going to create a new directory here that I name book. And inside that directory, I'm going to create a new Go file. That is a simple file that I name also book. And inside that file, so that will be the package book, I will have a type book based on a struct. And we are going to define some fields. So we will have an ID that is of type string. We will have the name that is of type string. We will have the author name that will be a string. And we can also have a create time, so the time at which we are going to create the book in the system. So it's going to be a time.time. And now I have time that is imported my ID. So I have my type book. So I want to store books. So then inside my storage, I'm going to define an interface, create book. And it will take as input a book dot book. So you can see that I have my import that is automatically added here. And in output, it's going to return an error because the creation of the book can fail. And by the way, why not just naming that create? Because we take as input a book, so why not just create? I have my interface. Now I want to create an implementation of my interface for MySQL. So we want to develop the logic to create a book into MySQL, to save a book into our database. So to do that, I'm going to create a new file, a new Go file, in the storage directory that will be named MySQL. And in this package, I'm going to create a type that I name MySQL storage. And it's based on a struct. You can note that the type is exported because the first letter is capitalized. So in other parts of my program, I will be able to import MySQL storage. Then I need to create the method create in order to implement my interface. So in my interface, I have just one method, so I have to implement that method on this type. To do that, it's really easy. You have to create a method on MySQL storage named create that takes as input an element of type book.book, right? And that returns an error. And then you can see that my IDE has automatically detected that I implement an interface. If I click here, I will see this interface. So the type MySQL storage implements the interface storage. Why does it implement the interface storage? That's because I have this method defined that has the same name and signature. So for the moment, let's return nil here. And we will need to implement that to do an insert into our MySQL database. The next step is to create a new function, a function that will initialize MySQL storage. So I've named that function new MySQL storage. And this function will return an element of type MySQL storage or an error. And here we have to make the connection to the database. So in order to make the connection to the database, we first need to install a driver. The standard library of Go is not shipped with a MySQL driver. You have to install it. There is one driver that is really popular. This is this one. So the module path is github.com/go SQL driver/MySQL. To install it, it's not really difficult. We're going to copy the path of the repository, so github.com/GoSQL driver/MySQL. And then we're going to open our IDE, and inside the terminal, we're going to type go get-u, and then the module path. So it's going to add the driver to our code. And then we will need to import it, but with a blank import. So let me show you how to do that. So you're going to have to type here underscore, and then you have to put here the path of the module. So what does it do? When you do that, it's going to run the init functions that are defined here. So here you can have many init functions that will be run here. This is the standard way of adding a driver to your code. So you do the blank import, because you're not going to use internal functions from the driver, but you just need those init functions to run in order to register your driver. Then you're going to use the standard library to interact with your MySQL database. Once you've done that, you will be able to open the connection to your MySQL database. So let's do that. So we're going to use SQL.open, and then we have to give the driver name. So the driver name is MySQL, and then the data source name. So the data source name is where is your database, and what is the username and the password, in short, and which database you are going to use on that database server. Okay, so let's construct this DSN. For instance, the moment let's put an empty string. So I'm going to create a new variable here named DSN, and then I'm going to use fmt.printf in order to construct that DSN. So we have to have the username, password, the address, the port, and also the database that we are going to work with. So I'm going to create a new type that I named MySQL config, and in this type that is based on a struct, I'm going to list everything that I need. So I have username, that would be string, password, that is also a string. I will have also a DB name, or the database name. I will need also the port, which will be an integer. And by the way, we can put a new int, because there is no such thing as a negative port. And we can also put the host here, which is a type string. Then it's time to set up the DSN. As you can see in the README, you have an example of DSN. We're going to simply copy that and then paste it into our project in order to replace it step by step. So I copy that as first arguments of the printf, and then we will need to replace the username by the real username and the password, etc., etc. So to do that, my new MySQL storage will need to have an input parameter. Let's call that conf, so it will be of type MySQL config. And then I replace it step by step. So %s for username, so I have to use conf.username. For the password, it's going to be %s, it's a string, so conf.password. Then the protocol, so we will talk with the database with the TCP, so it's TCP. And then the address, here we're going to put a %s for the host, and then a %d for the port. So it's going to be conf.host for the first, and then conf.port. And then we have to give also the DB name, so %s again, and then we replace that by conf.dbname. We can remove this parameter here, not necessary. Then I can use this variable here, so DSN, and then SQL open will return a pointer to an element of type DB and an error, so I create a new variable DB and error, and I have to check the error. If the error is different than nil, then what I'm going to do is I'm going to return an empty MySQL storage and the error. But I can do better. I can return fmt errorf, and I'm going to add some context to my error. So impossible to open SQL connection. And then I add the error with %w, and %w means wrapping the error. The caller will be able to unwrap the error. I'm going to do a video in order to explain that. But for the moment, remember that when you want to return an error, it's always good to add some text in order to describe the error, and then use %w in order to inject the error and allow the caller to unwrap. The function new MySQL storage need to return an element of type MySQL storage. So let's do that. So if I succeed into opening the connection, then I can return my object and then nil here because everything went well. And then on my MySQL storage, I need to have this, so the pointer to the DB, in order to make operations on the DB. So I'm going to create a new field here that will be of type SQL.db, and it will be an element of type pointer to SQL.db. And then I can set here the field DB, which will be equal to DB. All right, our new MySQL storage is done. So then when I have this create function, I will be able here to do a request to my database. I will be able to do a query, and it will be an insert query. First, I would like to test that new function against my database. Let's do that. So I go to the main.co, and then I'm going to create my MySQL storage. So let's call that store, and I'm going to call storage.new MySQL storage. I should give a config, so it's going to be a storage.mysql config, and then we're going to fill all the fields. And by the way, it can also return an error, so we have also that. So if the error is different than nil, then we have to exit our program. So we can use log.fatalf in order to add some details. Impossible to create MySQL storage, and then %s, and we are going to add the error here. So the username will be root with Docker Compose. The password, this is the password that is set up here, example. So let's modify the password here. The DB name, do we have a database created? I'm going to put here DB. So the port, I have to check the Docker Compose, so 3006. And then the host, it's going to be named DB. Not DB, sorry, it's going to be named database, because when you are inside Docker Compose, so the service name will be also the host. So it's going to be database. Then on my store, I can just log it, for instance, here. And the idea here, so after that, I can use my storage here. The first step is to make sure that you have your Docker Compose stack up. So I'm going to type into my terminal Docker Compose and then up. It will create the container and start the container. What we can do now is to run our program. In order to do that, I open a new terminal and I type go run main go. It will compile and run the program. So you can see that we have that is printed on the screen. So it means that we are here. Why? If we had an error, we would have this fatal, and fatal will exit the program with a status code equal to 1. And when you run that, you will have that status code printed. It's going to print process exited with status 1. So here it means that everything went well. Let's try to do an experiment, and I'm going to stop the database. So I press Ctrl+C in order to stop it. And then let's try to run again. And here you can see that we have a similar output, but we don't have the program that is exiting with log fatal. It should not work, no? let's take a look at our new MySQL storage. So it's calling open, and you can see that in the documentation that open opens a database connection. Okay, you can see here that open may just validate its argument without creating a connection to the database. To verify that the data source name is valid, call ping. So this is what we are going to call now in order to check that we have a good database connection. Otherwise, it's just checking that the DSN is correct. So let's go back, and then we are going to try a ping. So we're gonna call db.ping. And then if we have an error, we're gonna have the same treatment here, except that the message will be impossible to ping database. Let's try to run our program again. So go run main.go in the terminal. And you can see here that I have an error. It says impossible to ping DB, dial TCP, lookup database, no such host. So the error is on the host. So here for the host I put database. This is wrong. I cannot use the service name as host when I'm trying to contact the container from my local machine. Here I'm in my local machine, I'm not inside a container. So I should use localhost instead. I could use database if my application were running inside a container. Let's try to run the program again. And you can see here that we have a weird error. It says unexpected end of file, and we have an error in packets.co at the line 37. So here inside the driver. So this is really weird. So if we take a look here at our main.go, you can see that I use the port 3006. So it looks okay. And here on my ports is 3006 and 3006. I made a mistake here again. So here the ports should be changed. The default port for mariaDb is 3306. So what I need to do, I need to change the container port to 3306, and I can also put 3306 here to contact him from the port 3306 on my local machine. So I did change that. So there is one thing that I should do. I should stop my Docker compose up, and I will run docker compose up -- force recreate in order to recreate the container. So let's go. All right, it seems to be done. And now let's try to run the program again. So we still have an error, but it's different. It says connection refused to the port 3006. So let's fix that. Here I should put 3306. So it should be the same as the host port. Let's try to run again. Then I have an access denied. So it seems that the connection, I can connect, but my access is refused. So it means that I don't have the right username password. So in order to fix that, we can set up environment variables. The environment variables to set up in your docker compose.yaml are the following one. So MySQL user password, so username and password, the database, and the root password. So you may know that on a database you have a root user that you can use in order to perform whatever you want, but it's more advised to have another user that is not the root user. And here I have this user that is username user and password. So I'm going to use that in order to connect. So I need to change my main.go. Here inside username, I should put username. Inside a password, it's password. DB name, it's DB, it doesn't change. The port is correct, it should be this one, because I'm on my local machine. And the host is localhost, it's correct because I'm on my local machine. So let's try to run that again. Go run main go. It says access denied. Why does it say that? That's because I changed my environment variables and I didn't reboot all my containers, didn't recreate my containers. So I need to do that first. So I'm pressing Ctrl+C here And then I have to run docker compose up force recreate in order to recreate the container. That's working. Let's try to run that again. It says access denied for user username. I made a mistake here. It's should be user and not username. Here it's user, so it should be user. Now let's try to run the program again. So go run main.go. Here you can see that I still have an error, but I changed my Docker Compose environment variable, so it should not raise an error. So this error made me lose like 30 minutes of building this video. What I did, if you remember, was to press Ctrl+C in order to stop Docker Compose. When you do that, and then when you run that again, if you change your environment variable that are defined in the Docker Compose file, it's not actually updated. So instead of doing Ctrl+C, so you can still do Ctrl+C if you want to have access to your terminal, you should do Docker Compose down in order to stop all the containers and remove everything. And then you can run Docker Compose up force recreate. Let's do that. So the database server will start. And then we can try to launch a request. So I open a new terminal and then I type go run main.go. And normally we should be okay. And here we are okay. So the ping succeeded. Oof. We can connect to database. Now I would like to have some tables in that database in order to test properly my application. So I will create some SQL scripts in order to initialize that database. So let's get started. I'm going to create a new directory that I'm calling docker and then db init. And in that directory, I'm going to create SQL scripts in order to populate the database. So I'm going to create a first script. I'm calling that init.sql. And here I can put my SQL queries in order to initialize the database. I propose to use this script in order to create the table book. So we have a column ID, create time, update time, that are of type timestamp. We have a column name, that is varsha255, author name, that is varsha255, and a primary key, that is ID. And ID is auto-incrementing. Now that we have our init script, we want the mariaDb container to run that script when it creates. To do that, if you take a look at the mariaDb documentation, you have to put these files into this directory. To do that, I will need to modify my Docker Compose file. I will add a key that is named volumes. And in that key, I'm going to specify which directory I want to put into the container. So it's a little bit like the port directive here. So the idea here is to put first the path of the directory on your local machine. So here it's in the directory docker here, and it's db init. And after the colon, you're going to put the path inside the container. So it's going to be / docker entry point -init db .d. Just a small word about volumes with Docker. So when I add that, it means that this directory on my host, on my machine, it's going to be replicated into this directory on the container. We create a shared volume between my local host and the Docker container. So everything that is inside db init will be inside this directory, docker-entry point-initdb.d. In order for that to be applied, I'm going to run a Docker Compose down. And then we are going to up again the container. So Docker Compose up -- force recreate. Now I would like to test if this change has been done successfully. So to do that, I'm going to connect to the database as my user that is created here. So I run Docker Compose exec database. I put the service name, so if I want to connect to another service, I change that. And then I'm going to ask for the mariaDb command line, and I will connect as the user, so -u, then the username, and then with the password, which will be password. So -p and the password. Let's try that command. I'm connected, so I can run show databases in order to list all the databases that I have here. So I have two databases. So this one is created automatically, and this is our database. So I'm going to use db, okay, and then I'm going to run show tables in order to display all the tables. So you can see that we have one table, that is book, that has been created. So my init script is working. Now that we have our dev setup ready, I'm going to finish the implementation of this create method. So the first thing to do is to create a variable query that will contain the query. So I will need to do an insert into the table book, and I'm going to insert the following row. So create time, so the colon create time will be set. I will also set the name of the book and then the author name. And what will be the values? So I put values here and then a parenthesis. So for the create type, I'm going to put now. So I want the current time to be set. And then I will put those question marks in order to define what we are going to put into name and author name. Then the next step is to run on my database, so s.db, I'm going to run exec context. And why do I use exec context and not just exec? Because the two methods exist. It's better to use exec context because with exec context we are going to pass as first argument a context. And the context will allow you to propagate in your calls timeouts and also cancellation signals. So let's say you have a server and you have an API call that will make an insertion into the database. If the duration of the insertion goes over a certain amount of time, you will be able to cancel the call and propagate this cancellation to your database. So I use exec context, but in order to use that, I need to modify my input parameter for create. I need to add a context here. So I name that setx, and the type will be context.context. But since I add another input parameters to my method, it doesn't follow the interface, so I will need to just change my interface. So I add the context here, so ctx and of type context.context, and I will also give a name to the book, and now it's good. So I can pass the context. So the first argument will be the context, so ctx that we got in input, and then the second argument will be the query, and then we can give the values that are expected here in the order that they are expected here. So the first one will be the name, so we're gonna get b.name, and the next one will be b.author name. And exec context will return the result, so let's call that insert result and an error. So when we have an error, we want to return an error. So if error different than nil, then I'm going to return an error. And as usual, I'm going to wrap the error. So error while insert, and then I put a colon and %w in order to wrap the error. With the insert result, by the way, there is a small typo here, we are able to get the ID of the book that has been created. And if you remember, in my database, I have an ID column and it's set to auto-increment. So the value will auto-increment. It's going to be 1, then 2, 3, etc., etc. So it might be interesting to retrieve that ID because I insert that and I want to have the ID here. So by the way, the ID here is a string. I'm going to modify that and put an int here because if I take a look at my table structure, here ID is an int. So we'll retrieve this ID. So to do that, I'm going to use insert result dot last insert ID. And this method will either return the ID or an error. So ID and an error. So I will handle also the error while getting last insert ID. I wrap the message and then I retrieve that ID. So now what do I do with this ID? I would like to return it to the user, so I will need to slightly change my interface. Here I will also return the book that I have created. So book.book and then an error in order to return the book. Okay, so the method is ready. Now it's time to test it. So I'm go back to my main.go and I'm going to use store in order to call create. So I'm going to give as first argument a context. So I'm going to create a new context with context.background. And context.background doesn't have a timeout or limit. It will just wait until we have the result. And then we can give the book. So book.book. The ID, I'm going to leave it like that, so default 0. The name, I'm going to put Practical Go Lessons. Author name, I'm going to put my name. And then for the create time, I can put time.now. And by the way, with the create time, we don't use that in our query. So we use b.name and b.authorname, and the create time, the value will be equal to now. I want to change that behavior. I would like to insert the create time that is passed by the caller. So I'm going to just add b.createTime here. That way, when I call create with the book and I fill the create time, this will be what will be in the database. Alright, so I have to check the error if something goes wrong. So I'm going to check the error and the message is going to be impossible to insert. And I'm going to log also the error. And then I can use log.println in order to print the book that has been inserted into the database. Alright, so let's test this script. So I open a new terminal and then I'm going to run my program. So go run main.go as usual. Right, so you can see that we have this that is printed on the screen, so it seems that it worked. So if we go back to our console, I'm going to select everything from book and see if we have our book. And you can see that we have the create time here that is set, we have the name and the author name. So it seems to work. Alright, so we'll stop here for the moment. I will probably do another session about storage because it's at the heart of each project with Go, generally speaking with microservices. I will just add some to-dos to the project. So here, I do not like the fact that we return a book. While returning a book, we should return only an error, right? I create a book, I expect just an error if my book is not created, but why returning the book? We are forced to do that because we have this ID column that is in auto increment. And so we cannot give an ID to our database and then set the ID. So maybe if we want to not return a book, we will have to modify that column and maybe put a string info into the ID. And when I insert it in my storage, I'm going to insert the ID classically. The ID field of book is int64, and we have been forced to modify that type in order to fit with the database. I would suggest here maybe to use a string, like it was before, and maybe populate with a unique ID. So you can use a library that generates a new ID and then insert that into your database. Why do I say that? That's because for some databases, you don't have this integer ID. You have a string, and generally we put UIDs in the ID. So your code will be more adaptable to other databases, not only MySQL. Another thing that I want to say is that for those two fields, so name and author name, a string can be very large. And in our database structure, we have only varchar 255, so varchar 255. So it's limited to 255 characters. And we didn't check that before inserting, we didn't check that the name and author name is not greater than 255. It can be a risk in your current implementation. So I'm going to add a to-do. Check the input. Checking the input parameters is really important in an application. It's going to improve the security of your application. This is almost the end of this session, so what do you need to remember? You should always test your database interaction code with a real database, and Docker Compose is a great tool to do that. In order to start your Docker Compose stack, you're going to type in your terminal docker compose up and then -- force recreate if you want to force recreate the containers. Then in order to stop, you're going to use docker compose down. For the ports and the volumes, it's always the same pattern. You have the host, then a colon, and then the container. So the host port and the container port. For the volumes, it's going to be the path of your host, so your local host, and the path on the container. With the go blank import, you will run init functions of the package that you import. And this is what we are doing when we are going to import our SQL driver. We use a blank import. Then I want you to remember that Go is not shipped with a DB driver, you have to install one. And you will need to install another one if you want to contact another type of database. Then one important thing, you should pass the context to your storage functions. It will allow you to control the timeouts and the cancellation propagation in your application. And by the way, it's not only for storage. If you have an API call, you want to have a context with that. Then you should validate the input of your functions and the input of your code in general. If we take the example of varchar 255, then if I give a string that is greater than 255 characters, then it's going to be cropped. And we don't want that. So thanks for watching. This video was a bit long, 50 minutes, and I want to have your opinion about that. Is it too long? Tell me what you think in the comments. And again, some links to follow me. practicalgolessons.com, you can read my book about Go. There is the online version free, but you can also buy the digital version or the paper version to support me. I also have a Go course on that website, 32 hours to build a real-life website. You can also follow me on Twitter, LinkedIn, and YouTube. So see you later!